happen? When you have what kind of triangles? Right triangles. Yeah, you have to have right triangles to have a hypotenuse. Okay? So this theorem that you're going to learn is only effective for only effective if you have right triangles right under your leg, like your chair leg. Okay? So if you don't have right triangles, you cannot use hypotenuse leg. If you don't have right triangles, you cannot use hypotenuse leg. So the hypotenuse leg theorem says this: if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and the leg of another, then the two triangles are congruent. So there are two things that you have to have when you think about that. You need to show that the hypotenuse, it's actually really called hypoteni. Plural of hypotenuse is hypoteni. So you need to have two congruent hypotenuses or hypoteni, and the legs, doesn't matter whether you do the short leg or the long leg, but it's got to be stated that it's a right triangle. If it's not stated that it's a right triangle, you have to prove it's a right triangle first. You have to have a right triangle in order to use hypotenuse leg. So we're going to kind of walk through that and talk about where it came about, because this is hypotenuse leg theorem. So really, in order for us to use it, we should probably prove it. Remember, theorems you have to prove. So in the diagram below, it says triangle ABD and triangle CBD are given such that segment BA and segment BC are equal. It's the same thing as saying they're congruent. So go ahead and mark them. Segment AB is congruent to segment BC. It also says that segment BD is perpendicular to segment AC. How can I show whoever is looking at our picture that segment BD is perpendicular to segment AC? What kind of angles? 90-degree angles. Yep. Do I need to put one on both sides, or can I just get away with doing one? You can do just one if you wanted to. I can do just one because parallel to the other side. Well, it's not parallel, but that's a straight line, and so those two angles make a linear pair, right? Okay. So it says, mark what is given on the triangle and explain how you knew. Well, we know that angle ADB and angle CDB are right angles because perpendicular lines form right angles. Because perpendicular lines form right angles. What two sides of the right triangle are marked? So if you think of these as being two right triangles, what do we have marked as congruent right now? What is this side of the right triangle called? And what is this side of the right triangle called? What's the longest side of the right triangle, or the side opposite the right angles? It's called the what? Hypotenuse. Okay, so right now we have both hypotenuse marked congruent. So the hypoteni are marked congruent to each other. Are there any other angles that you can say are equal to each other? Well, I don't want you to think about the whole triangle like as two separate pieces. What if we think about it as just one great big triangle for a second? Just one great big triangle. What kind of a triangle has two congruent sides? It is isosceles. So this is an isosceles triangle. Triangle ABC is an isosceles triangle. And we know that if the two sides are congruent, the angles opposite the two sides, are also congruent. They're called the base angles. So are there any other angles that are congruent? Yeah. Angle A is congruent to angle C because base angles of isosceles triangles are congruent. Now, it's unfortunate that we don't teach like geometry as a whole section because we're throwing in, like, it's been forever since you guys have probably worked with isosceles triangles and equilateral triangles and stuff. And we're trying to like pull things like out of your memory bank that you learned maybe in 6th or 7th grade. So you don't remember any of it? Okay. Well, I'm sure that you were taught it at one time. So what theorem can we use to justify that right now, what theorem can we use to justify that triangle ABD is congruent to triangle CBD? Well, we have an angle. We have angle, side, angle, side.
Oh, that spells booty.
Angle, side doesn't spell booty. So triangle ABD is congruent to triangle, hang on a second, CBD by angle, side.
Wait, why is it spelled like that?
Why is,
Never mind.
okay. So we prove that they're congruent by angle, side. And then remember, if triangles are congruent, all of their corresponding parts are congruent, right? All of their corresponding parts are congruent. So if these two triangles are congruent to each other, then all of their corresponding parts are congruent. Well, we know this is congruent to itself, reflexive. We were given at the beginning that this is congruent to itself. This is a hypotenuse, this is a leg, and we already have two right angles. So we know that we can use the hypotenuse leg theorem as long as we have a right triangle, okay? So that's the proof that the hypotenuse leg theorem works, okay? Does that make sense? All right, let's keep going. So in the next exercise or the next example, it says that segment CD is congruent to segment BD. So go ahead and mark it. CD is congruent to BD. It also says that segment CD is perpendicular to segment AC. So I have to show that by putting in a right angle. And segment BD is perpendicular to AB. So I have to show that as well. Okay. So how can we use those two perpendicular segments to say that we have two right triangles? How can we say that? Go ahead.
Wouldn't you have to put another angle in?
Hang on. It's not saying, so it's just asking us to say, how can we say that the two triangles are right triangles? I just want you to say that they're right triangles. That's what we have to say. So we have to say, we know perpendicular lines make right angles. So triangle ACD and triangle ABD are both right triangles. That's how we know they're both right triangles, because the perpendicular lines formed the right triangles. Okay. Well, what other piece do you know to be congruent? What other piece do you know to be congruent without us having to have something given? Look at that picture. What's the shared piece? Yeah, AD. We know that segment AD is congruent to itself by what property? I tried to write it like 5 times yesterday, and I've written it once today. What property says something is congruent to itself? The reflexive property. Okay. So do we have enough? Let's see. We have two right triangles. We just marked that AD is congruent to AD, which is the hypotenuse, right? And we have that given that CD and BD are congruent to each other. Those are legs. So do we have enough to say hypotenuse leg theorem? Yes, we do. Triangle ACD is congruent to triangle ABD by HL, by hypotenuse leg. All right. The next proof that we're going to do, I'm just going to kind of like list the reasons. And then the next 4 that we do, we're going to write statement, reason, because that's what you're going to have to practice. So I'm going to turn the page and we're going to do number 3 just normal. So let's just look at number 3 and we'll try to list what's given to us. So it starts off by saying given segment RS is perpendicular to segment TS. So that means that I have a right angle. It also says that segment RV is perpendicular to segment TV. So I have another right angle. So the first thing I'm going to do is I'm going to say that triangle RST and triangle RVT are what kind of triangles? They're right triangles because perpendicular lines make right angles. Okay, so we have 2 right triangles. That's good. All right. What else is our given? Well, we're told that ST is congruent to VT. Okay. Do you see anything else that we can say? How could we say that these 2 triangles were congruent to each other? We're missing one thing. Yeah, the one in the middle, the shared side. Segment RT is congruent to segment RT by the reflexive property. It's congruent by the reflexive property. Okay. So we've already said that we have right triangles. We were given congruent legs, and now we have a congruent hypotenuse. So can we say that the 2 triangles are congruent? Yes. So triangle RST is congruent to triangle RVT by hypotenuse leg. And that's it. We've proved that theorem. So for the next 5, we're going to do 5 more. We're going to make a table, like a T-chart kind of. Okay. So it's going to set up like this: statement, reason. Statement and reason. So when you do an actual proof, you have to list your givens, and the reason for it is just given. Okay. So as you read what is given to you, you want to mark it on your triangle and then write it down as a given. So our first given is segment CM is congruent to segment DM. So statement number 1, segment CM is congruent to segment DM. What is reason number 1? It's because it is given. It's because it is given. Number 2, the next given, pair of perpendiculars. Do you guys see that? Pair of perpendiculars. I'm going to write both of those together. I'm going to write both of those together in one statement. So statement number 2 is that segment CA is perpendicular to segment AB and segment DB is perpendicular to segment AB. And the reason for that is given. And I'm going to mark those perpendiculars by making right angles. All right. So every time you write down a statement, you want to think, okay, what can I say next? So what does perpendiculars two perpendicular lines give you? What do perpendicular lines give you? They give you right angles. So that means that triangle what and triangle what are right triangles. So let's say that. Triangle CAM and triangle DBM are right triangles. Why? Well, because perpendicular lines form right angles and triangles with right angles are right triangles. Typically, I just write perpendicular lines form right angles, definition of right triangle. So I always write this statement, but usually instead of writing triangles with right angles or right triangles, I usually just write definition of a right triangle. Definition of a right triangle is that it just contains a right angle. Okay. So now what? What else can we say? Well, it says that M is the midpoint of segment AB. M is the midpoint of segment AB. And that's just given. But what does it mean for M to be the midpoint? What does the midpoint do? We already learned the midpoint theorem, right? We know what a midpoint, like we know what a mid-segment is. A mid-segment cuts the two middles of the triangle, right? It takes the midpoint of the sides and hooks them together. So what does the midpoint make? Doesn't share a line. If M is the middle, if this point right here is the middle of this whole segment, what does it mean about AM and BM? They're the same. Yeah, they're congruent to each other. We know that AM is congruent to BM. Let's say that. We know that segment AM is congruent to segment BM. And that's just definition of a midpoint. So let's see. We said that we had right triangles. We now have marked congruent hypotenuses or congruent hypoteni and congruent legs. So what can we say about those two triangles? We can say that they're congruent to each other. Number 6, triangle CAM is congruent to triangle DBM. What reason? Hypotenuse leg. Okay. If everyone goes to page 36, the two proofs on like 1 and 2, they each have 4 statements. And then the next 2 have 3 and 4. Is everybody good with this? Okay. So number 36, we're on page 36, number 1. So it says C is the midpoint of BD and AE. So that's my first statement. C is the midpoint, and you can abbreviate, of segment BD and segment AE. Sir. I just abbreviated statement and reason, STMT and reason. So that first reason, like why can we say C is the midpoint of segment BD and segment AE? Well, because it's given to us. It's given right here. So we have to mark it. We have to mark it. Well, what does it mean if C is the midpoint? We just talked about that. What does the midpoint do? If C is the midpoint of this whole segment, what does it do? It was the last statement that we just had before we proved on the proof right before it. So look at example number 4. What did we use that for? What did we say? What does the midpoint do? It makes what?
Piece of what? Sorry.
That's okay. What does the midpoint do?
Oh, it means that AC and DC are equal.
It means that BC and DC are equal. That's right. So let's say that. Segment BC is congruent to segment DC. Why? Definition of midpoint. But it says that C is the midpoint of segment BD, and C is also the midpoint of segment AE. So what does that mean? It's the same for that side. Yeah, exactly. So I'm going to write it with the same statement. It also means that AC, segment AC, is congruent to segment EC. So do you see how we use what's given to us to like build a proof? Okay. So now what? What do you know about angles? What do you know about angles?
On the thing up top, they're I'd say 90.
You can't assume that you have 90 degrees.
Like they're, whatever that word is called, congruent.
How do you know that those are angles are congruent?
They're vertical.
They're vertical. Yeah. So let's say that. So we know that these two angles are congruent. So that's going to be our third statement. Angle ACB is congruent to angle ECB because vertical angles are congruent. So can we prove that those two triangles are congruent now? Look, do you have a theorem that says something about a side angle side? Side angle side. Do you have a theorem that lets us prove triangles congruent by side angle side? We do. So statement number 4 is what you're proving. You have to write it just the way it's written. So triangle ABC is congruent to triangle EDC. This should be ECD. Sorry, this should be ECD up there. So triangle ABC is congruent to triangle EDC by what method? Go ahead. Yeah.
I don't know. I was just gonna say, does it have to be in order like that?
Yeah, you have to write it exactly the way that it's written here. Well, oh, you mean how do your proof? You know where your proof starts?
Does that have to be ABC?
Yes. This one is talking about the angle ECD. So that's this angle right here. Okay, are we good with that one? Let's move up to the next one. So statement and reason again. Statement and reason. So the first statement that I'm going to write down is this first given. I'm going to write down this first given. So my first given says that segment AB is congruent to segment CB. That is my first statement, and it's given. So I'm going to mark it. AB is congruent to CB. It says that segment BD is the median of segment AC. It says that segment BD is the median. That's the next statement I'm going to write. So segment BD is the median of segment AC. A median is just a line. Instead of a midpoint, it's like a middle line. It's just like a midpoint, but it's a whole segment, right? So BD basically is the middle segment. It's the segment that cuts what in half?
the hypotenuse.
What is segment BD cutting in half? Segment BD is cutting what whole segment in half? Yeah, it's cutting AC in half. So what does that mean? What can we say? If segment BD is cutting segment AC in half, what is it creating? Two congruent pieces. So that's what we're going to say next. That segment AD is congruent to segment CD. That's just the definition of a median. Definition of a median. A median is made from its midpoints. Okay. All right. What else do we have? The shared side. Yeah. I'm going to put 3 congruent marks on it. We know that segment BD is congruent to itself. What's the reason for it? Because there's no such thing as like shared side. Reflexive property. Okay. So do we have what we need to prove that these two triangles are congruent?
Yes.
Yeah, we do. How are we going to prove it? SSS. So we have to say it just like it's written here. So triangle ABD is congruent to triangle CBD by side, side, side. Two more. You guys are doing great. You're almost done. When we're done. Almost done. These are short. These are short. This is going to help you get through what you're doing tonight. Okay. Are we good with this? Okay. So number 3 and number 4, go ahead and make your T chart or whatever and write statement reason. Statement reason. Get it ready to go. S and R? Yeah, I don't care. As long as you know what it is. Okay. If you guys ever have a test with a proof on it, I always set that up for you. And typically I number it so you know exactly how many statements and reasons you have. Does that make sense? Otherwise you could be trying to solve it forever.
Yeah.
Okay, so what are we going to do first? We start with our what? You start with the givens. You always start with your givens. So our first given, segment AB is congruent to segment DE. Given. AB is marked congruent to DE. The next statement is also about congruent segments. So I'm going to put them on the same line. Like I try to group them if they're the same thing, like we did the 2 perpendiculars, I put them on the same line. So segment BC is also congruent to EF. That's given. So BC and EF. Okay. Well, we have one more given. Statement number 2 says that angle B is congruent to angle E. It's another given. Angle B is congruent to angle E. So Carter, do we have enough information to say that triangle ABC is congruent to triangle DEF? Okay, what theorem are you going to use? Mm-hmm. Perfect. So let's say it. Triangle ABC is congruent to triangle DEF. Why? By side, angle, side. When you guys finish a proof, you're supposed to like draw this little box. That just means that you're done with your proof. But
QED.
QED. Yeah, that little box doesn't want to stay for me. Okay. That just means you're complete. Your proof is done. Last one. See how it's like just a really thick bar. Last one. Okay. So who feels like they can do this whole proof? Okay, go ahead.
Well, on your statement, you're gonna have PQ is congruent to TU.
So segment PQ
And
is
that's given.
congruent to segment TU.
And you're also gonna have.
Hang on a second.
Sorry.
Let's mark it on our triangle. Make sure that we mark what we're writing down. So PQ, TU. Okay. Keep going.
And then you have angle P is equivalent, or not equivalent, my bad,
That's okay. Congruent.
congruent to angle T.
So can we put the congruent angles on this next line together?
You can put on the same line.
No, we're going to do another one. Angle P is congruent to angle T, and angle Q is congruent to angle U. You see how I'm grouping like congruent angles together, and on the other one we group together the congruent segments. Do you guys see that? Is that kind of making sense? Okay. So this is also given. It's not making sense? Oh, okay. Carter, is that making sense? Okay. So angle P, we said it was congruent to angle T, and angle Q is congruent to angle U. Okay. Keep going, Tyler.
And I'm pretty sure that that's enough.
It is enough.
So you're gonna have ASA, I think.
Well, what are we saying? What are we writing down for our statement?
Oh, triangle PQR is I don't remember that word.
Congruent.
Congruent to triangle TUS.
Perfect. And what reason is that?
ASA.
Perfect. Thoughts?